All right, guys, I'm going to go over the 1.3 notes. We got them in class last week. So we did a KWO chart. That was just kind of get you to, kind of to force you to kind of read through some of these notes. You might not have known a lot of things about these notes, but hopefully after this, you're going to know a lot of things on these notes. So, we're going to start off with, today we have to remember what foil is. So we talked about foil before. One of your last fire starters was kind of all about foil. So, X goes to X. Those are the first two. Like, I think distributive property, but X goes to X. That's the foil part. Then X goes to 4. That's the outside two. Then the inside two are 7 and X. And then the last two are 4 and 7. And that's how I'm going to take two sets of parentheses. So foil takes two sets of parentheses, makes the parentheses go away, and combines like terms and turns two binomials into one trinomial. All right, that's what happens here. X goes to X. So like I said, I think of it as distributive property. X goes to X gives me X squared. X goes to X gives me X squared. X goes to 4 gives me 4X. 7 goes to X gives me 7X. 7 goes to 4 gives me 28. The like terms, remember X squareds can only go with X squareds. X's can go with X's. Only numbers can go with numbers. So my after I FOIL is X squared plus 11X plus 28. So some keywords, right? A monomial is an algebraic expression of one term. So if you have one term, it's a monomial. So just X or just 7. They can be combined, like 7X plus 4X. Those are two terms, but they can eventually put together to 11X, which make that a monomial eventually. A binomial. Two monomials that cannot be combined. All right. A trinomial is three monomials. Now they're always going to be adding or subtracting. So it's going to be x plus 7 as a binomial, x squared plus 11x plus 28, or x squared minus 11x plus 28. You're never going to have multiplication because that could be distributed further. And we could say cannot be combined further might be a better way to add that. All right. And really important, like terms. Like terms are terms with the exact same variable to the same power. So x squared and x are not like terms because they cannot be combined because they are not the same exponent. Alright, so I made this up because if you're lost, when I talk about factoring today, you're going to use your GPS. All right, if you're lost and driving around somewhere, you're going to use a GPS. So you're always going to start at the top. So you're always going to start and look for something in common first. All right. If there's something in common, you just count the number of terms. If there is something in common, you factor it out. So like here's an example of something in common, like 6x plus 12. 6x and 12, both of these can be divided by 6. So I take out the common 6. That's 6. That's called factoring out the common monomial. That's taking out one term that they have in common. If they both have an x, so an example of common stuff, something in common. So let's talk about stuff in common. So if I had something in common, like let's say 3x squared plus x, right? Both of these have an x in common. So I could take out the x. Right, that's an example of factoring out the common term. They both had a common x. Here's it, like both this and this are divisible by 6. So I take this 6 outside, and look, 6x plus 2 does give me 6x plus 12 if I use distributive property. Like here's an example of 3x squared and 4x. They both have an x in common. They both share a letter or a number. So a lot of times I'll say something like that. I'll say, do they share a letter or a number? That's a common term, all right? So that's a common thing. Now, if that happens, you do that first, and then it's like a flow chart. So even then, you're going to count the number of terms, and I'm talking about that's going to tell you what method to use. I'm going to give you some methods that we're going to use, and once you use those methods, your life's going to be a little bit easier. All right. So we'll talk about how to use these methods. If there's 3 terms, here's some steps you're going to follow. If there's 2 terms, here's some steps you're going to follow, and we're going to go from there. The other thing you're going to want to know for sure is you're going to know these perfect squares. This is going to be very, very helpful to know these perfect squares. All right, perfect squares. I have a feeling we'll have a time test over perfect squares just to make you learn them. So you're going to want to know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, because 4 times 4 is 16, in case you don't understand how I'm getting the squared part. 5 times 5 is 25. 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225. All right, that's how we're going to do that. Anybody, we're going to talk a little bit more about perfect squares, and we're going to come back to this almost every single time if we're lost. All right, factoring is the inverse, or kind of like opposite, of FOIL. It makes a trinomial product of 2 binomials. So before, I would have 2 parentheses, and they would turn into 1, 2, 3 terms, right? Now, I'm going to have 3 terms, and I'm going to turn it into the 2 parentheses. I'm working backwards. Think about it how when you guys learned how to use order of operations, then we learned how to solve because we worked backwards. All right. So I want to turn my FOIL product, or my trinomial, into 2 sets of parentheses. There's going to be a reason for that, and it's going to help us solve, because this is going to be really hard to solve because I cannot use, well, one, I can't even solve any of these to start because they're not equations. But more importantly, I'm not going to be able to solve because they're not an equation yet. But so this is kind of like trinomials version. Our goal is to eventually solve. We're just not there yet. All right, so I want to factor the expression. So I'm going to use my GPS because I'm lost, right? You're lost. Use the GPS. So the first thing to do is I'm going to look for something in common. So like guys, you'll have this on a quiz. This is going to be something to use all the time. Factor the expression. X squared, 9x, 20. Do they share a letter or a number? Well, these 2 share an x, but not all 3 of them. Right? All 3 aren't divisible by the same number, so there is nothing in common. All right? So nothing in common here. So now I count the number of terms. 1, 2, 3. So once I have 3 terms, I follow the steps. Step 1, factors of the first term. So I'm going to say, how do I get x squared? The only way to get x squared that I'm going to talk about is x and x. You could write x squared times 1, but that's not going to help us. So I'm just breaking down the first term. Those are the factors. Now I'm going to break down, so this is going to be step 2, is how do I get 20? Well, I could have 1 and 20. I could have 2 and 10. I could have 4 and 5. So it's just factoring, all right? Factoring a number, writing down all the multiples of a number. All right, now I'm going to check the middle using FOIL. So basically, guys, I know that the first term is going to give me the first part of my parentheses, and I know that the last could be any of these combinations. It could be 1 and 20. It could be 2 and 10. It could be 4 and 5. They could be positive. They could be negative. Right? So in reality, I could put x plus 1, x plus 20. I could put x plus 2, x plus 10. I could put x plus 4, x plus 5, because all three of those will give me positive 20. Now the other thing that tricks some people is that I also put x minus 1, x minus 20, because if I have a positive number at the end, right, those could be written any other, those could be two negative numbers will also give me a positive. So I could have x minus 2 and x minus 10, or I could have x minus 4 and x minus 5. Now the reason I'm going to choose x minus 4 and x minus 5 is because if I were to FOIL this, x goes to x, x squared. X goes to minus 5, minus 5x. Negative 4 goes to x. Negative 4 goes to minus 5. So if I FOIL this out, it's going to turn to x squared minus 9x plus 20. And that's what I want. So think of it like a combination. All right? Think of it like a combination lock. A combination lock has three numbers, and you have to do it in that exact order. Right? It matters. You might know all three numbers of a combination lock, but if you don't do it in the right order, you don't spin it the right direction, it's not going to work. And that kind of is like that here. And if you knew 2 out of the 3 numbers, you could eventually guess the third number. You just keep on guessing and checking until it works. So my actual answer here, this is where people get confused too, because we do all this work and they're like, what is the actual answer? The answer is the 2 sets of parentheses. So this part isn't the answer here, right? The answer, that's just me checking my work. The part I'm erasing right now is me checking my work. So the actual answer is this right here. It's just the 2 sets of parentheses, right? That's my answer. So my answer is this right here. So like B, how do I get x squared? X and x. How do I get negative 12? So notice that's a negative sign, right? That negative sign means that my factors of 12 have to be opposite signs. So I could have negative 1 and 12. I could also have positive 1 and negative 12. I could have negative 2 and 6, or positive 2 and negative 6. I could have negative 3 and 4, and 3 and negative 4. All 1, 2, 3, 4, 5, 6 of these are possible combinations for this trinomial. Only one of them will work. So all 6 of them will give me a slightly different trinomial. If I told you to multiply all 6 of these out, if you built them and then multiplied them, they would all give you slightly different trinomials. So I need to find the one trinomial that will give me 4x in the middle. So that's basically the idea, is when we have a factor in an expression, we're trying to find the middle term. Because all these in common, all of those combinations will, if I start with an x and x here, all of them will end, or will begin with x squared when I finish it. Now, any of these combinations, I can do option 1, option 2, option 3, option 4, option 5, option 6. All 6 of those options will end with negative 12, but only one of those 6 will end with positive 4x in the middle. All right? So I have to pick which one I think is going to work. Now, what we're going to find out is there's a shortcut. If this is 1x squared, which it is, you can just do a little shortcut. If I put negative 1 and 12 in here, it's going to end up giving me x squared plus 11x minus 12. Not what I want. But I do notice that negative 1 plus 12 is 11x. So that's called our shortcut. Our shortcut says just add the 2 terms in the middle. So that's going to give me positive 11 in the middle. if I did positive 1 and minus 12, it would give me minus 11x in the middle. And a lot of times, guys, I won't check the whole FOIL. I'll just do the outside and the inside. So the outside would give me minus 12x. The inside would give me 1x. Together, that's minus 11x. Right? So I would do that instead of checking all of FOIL. So I don't want negative 11x, so that one's not going to work. I want positive 4x, which 6 plus negative 2 is positive 4. So I'm going to put minus 2 and plus 6. And guys, it doesn't matter if you put the plus 6 first or the minus 2 first. They're both going to give you the same answer. So you could check the whole thing using FOIL. So I do x goes to x squared. I'm going to do x goes to 6, 6x. I'm going to go negative 2 goes to x, minus 2x. And then I'm going to do negative 2 goes to 6, minus 12. Notice, every single time we've done it, we got the same beginning and the same end. The middle is what changes. Now, you could just do the green and the blue writing right here. You could just do the green, x goes to 6, and minus 2 goes to x to check your middle using FOIL if you don't want to do all that work. So remember, our answer is not this. This is not our answer. This is our answer, the 2 sets of parentheses, because that's our goal when we factor, is to take it into 2 sets of parentheses. All right? Keyword is
All right, now that I did all that explaining,
I'm going to go a little bit quicker now. So just because this video has been taking quite some time. So I'm going to use this GPS. Like if I'm lost, I'm going to use this GPS on your own factor expression. So it says factor, that's why I'm using the GPS. None of these three have anything in common. X squared and 3x does not share a letter for all three. 3 goes into 18, but it doesn't work for the first one, so they all three have to share a letter. So I'm going to say no. I count the number of terms, factors of the first term. So every single one of these, if you're struggling, the first thing you should do is break down the first term. Always very easy. How do I get n squared? N and n. How do I get r squared? R and r. Right? Easy. That's step 1. So that's the red writing. Step 2, factors the last term. Right? So how do I get negative 18? Notice it's a negative 18. So I have negative 1 and 18. I could also write down positive 1 and negative 18. I have negative 2 and 9. And I have 2 and negative 9. I have 3 and negative 6. And negative 3 and 6. All those are options. I want the one option that's going to give me negative 3 in the middle. Negative 1 plus 18 is 17. Not going to work. 1 minus 18, negative 17. 7, negative 7. I want negative 3. So I need this combination. X plus 3. X minus 6. This is my answer. Here's how I check it, though. This is the step 3 right here. Right there. That purple is step 3. I do the outside. Gives me minus 6x. The inside gives me plus 3x. Together is negative 3x, which is what I want right there. All right. So step 2, how do I get positive 9? 1 and 9, 3 and 3. Now here's where it gets really interesting, because 1 and 9, once again, I forgot. You could always write your negatives. So for a positive 9, you could also have negative and negative, and negative and negative. This equals 10. That's not what I want here. Can't be that. This equals 6. Not that. This equals negative 10. Not that. This equals negative 6. Not that. So guess what? This one is not factorable. There is not a combination that works for this one. All right. So I'm going to go through. Now this time I am not going to write both sets. I'm just going to write 1 and negative 63. And I'm going to know in my head that I could also switch it. I can make negative 1 and positive 63 show up. All right. 2 does not go into 63. So guys, this is how I figure out factors if you struggle with factors. I just divide. And 63 divided by 2 doesn't work. 63 divided by 3 does work, so that means 3 and negative 21 are a set of factors. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 times 9. So I get 7 and negative 9. So I know that my factors, I know it has to be R and R. That's the only choice. I have 3 options here, and actually 6 if I switch the signs. And negative 7 and negative 9 is negative 2. I want positive 2, so I'm going to watch. I'm going to take that, I'm going to make it negative 7 and plus 9 to give me my right answer. All right, and that's going to be it for today. I've already done quite a lot of talking, and we'll finish this. I'll make it a part 2 of this video for the next day. Keyword is Conneaut. Keyword is Conneaut.